Hello everyone and welcome back. Today's topic is the programming liquid level control in a tank using a pump with the variable frequency drive. And for this purpose, we will implement the cascade control where the flow PID controller FC is the subordinate to the level PID controller LC. And here we have, firstly, let's write down what we have here and how we will control it. Firstly, we have the flow control, flow PID controller, PID control. Next one is the level PID controller. And also we have the controlled object. Object is our LC. It's a tank level. Next one is the FC. FC, it's a pump flow. And also we have the final control element. It's our VFT, final control element. VFT, final control element. And we have the set point SE. The first set point is our desired level. First and second is our desired flow. SE is the desired flow. Also we have the process variable. Process var is the LPV. It's our actual level, and we have the FPV is our actual flow. And next, the last one is our output, is the controller output. And here we have LMV, is the required flow calculated by LC. Required flow calculated by LC. Calculated by LC. And the last one is the MFP, is the frequency calculated by FC. And the control sequence is the start from the LSV, then we go to LC, and then next step is our LMV, and also we can equal it to FSV. The next step is our FC. Next step is the VMV. Next step is the VFT. Next step is the pump. And last is our tank level. And shortly about it, my friends, the level controller determines the required flow, and the flow controller adjusts the pump speed to achieve that flow. This provides faster and more stable level control. And now let's open our system view. And let's open our input output models. Sorry, FCS input output model, and we need here our analog input, and here we add two variables. Sorry, two tags. First, it's the LPV, and next one is next one is our FPV. And my friends, again about the double person symbols. I think you remember from our previous lesson, but I want to say again, a simple way to understand this, why we use the double or single person and sometimes no person side at all, because when we use the double symbols of the person, it means that we register the name in the input output model. When we use the single person symbols, we are referring to the registered plant tag. And sometimes we used without the person sign. And in that time we using the tag in the control logic, PID blocks and calculation. For example, when we configured an analog input channel in our EOM editor, like now, we assign the double name. This is similar to creating a contact in your phone. Later we use the signal in PID controller. We simply write the name of LPV or FPV because the system already know what the signal in LPV is referred to. And let's write it like this. I think it will be good for you and for me. Define or register a tag name. And also we can say it's a symbolic name. And then when we use the simple sign of the person, it means that we reference a plant tag. And the last one we use the no person. When we use the tag in the control logic, use tag in control logic. So my friends, In the next lesson, we will try to build our logic, and we try to control the PID regulator. And that's all for today. And I wish you all, I wish you good health and good like. Subscribe to our channel and hit the like button if you enjoy the video and find it useful for you. See you in the next lesson.